Hello everyone, Namaste. It's me Javindra Paudel. Welcome to my YouTube channel. Today we'll continue from the previous session. In the previous session, we discussed about the concept of repair, restoration, and retrofit techniques, as well as the type of global retrofit. Today we'll continue the retrofit techniques with local retrofitting techniques. So, local retrofit techniques deals with the increase in the ductility of the structural components with adequate capacities to satisfy their performance limit. It includes the jacketing of beams, columns, beam column junctions, and strengthening of individual footing, in which most popular is the jacketing, which includes of reinforced concrete jacketing, steel jacketing, or carbon fiber jacketing. Jacketing is done with the around the existing members, which increase the lateral load carrying capacity of the structure in a uniformly distributed way, with the minimum increasing of load in foundation in a single foundation. It means the thickness of column jacketing or beam jacketing, as well as the junction, is low. So if we have the column of this section, and if we do the concrete jacketing, maybe it can be of minimum 100 mm thickness. Yeah, this thickness is 100 mm all around the periphery. And in this section, if we do the concrete steel jacketing, it can be like this in all the four corners. So the thickness is minimum in all these cases, so that there is negligible addition of load for the individual footing. That's why this type of jacketing is more popular in the member level of retrofit or local retrofit techniques. So the reinforcement column jacketing or reinforcement concrete jacketing increase the lateral load carrying capacity of the structure as compared to steel jacketing. This is a reference paper taken from this researcher. And steel jacketing provides a good bonding between the old concrete and the new concrete surface, and there is no any debonding observed between the two concrete layer. It was verified by doing the experiment at the labs with the retrofitted columns by this researcher. So if we look into this table with this researcher, the research done by this researcher, the cost of RC reinforced concrete jacketing and splint bandage is 33% and 22%, which is low among the cost of base isolation, which is 92%, and it is followed by internal concrete box, which is 84%, and steel strong point is 83%. Here it can be from this table, and the researcher concluded that the reinforcement concrete jacketing in the form of wrapping around the concrete surface and in the form of splint and bandage is the most economical way for the member retrofit scheme. So the column jacketing is the jacketing which is wrapped as the existing column member is wrapped with a jacket of concrete, reinforced concrete with longitudinal steel bars. Longitudinal steel bar. Here we see the steel bar. These are the additional longitudinal steel bars and the lateral ties, as well as the anchor bar with epoxy grout are used to bond between the existing this concrete and this one, connect the old concrete and new concrete surface. So based on this method, the actual strength, bending strength, and the stiffness of the original column can be enhanced. So this figure indicates the column jacketing as well as the strengthening of beam in the beam column junction, and this is the circular column jacketing rebar laying works. So if we look into the typical photographs here, these photographs speaks about the detailing of rebar in column jacketing. The foundation of this column has already been casted, and below the plinth level, and the rebar laying is as for the design, in which the rebar is concentrated more at the four corner of the column we see here, and the lateral ties as well as the ties to accommodate these column rebar at the edge, and the anchor bar to bond the new concrete and old concrete. And the concrete should be laid in a layer basis, multiple layer basis, to avoid the void or any honeycombs in the concrete, because the concrete surface, the thickness of the concrete surface is very low. It's around 100 and there is no possibility of inserting the vibrator needle. So it is better to make a self-compacting microconcrete. It means in microconcrete the aggregate should be 10 down, and if we have to vibrate, then we should have a plate vibrator to apply on this surface, this flat surface. So in this way the concrete microconcrete can be done. And in the top here there are four holes, four these corner rivers are continue up to the top level or up to the story on which the column is to be retrofitted. And the concrete, the slab concrete or the edge of the beam or cover of the beam is punctured here and make a hole. And at the top surface, the concrete can be poured from the top upper floor slab through the hole, and this joint can be accurately or can be sufficiently casted with microconcrete so that the voids can be removed and the junction can be strong enough to resist the earthquake load. Because in the case of earthquake, if we see the damage pattern of the structure, the damage are concentrated around the junction in the beam and in the column also. So the junction or the supporting uh, point, connecting point of the beam columns should be strong enough, should be compacted well, or should be casted in a better way to have better resistance to the lateral force. Because firstly, the nonlinear hinge or the yielding occurs in this zone. In case of beam, suppose this is a beam, this portion is the first yielding portion or hinge formation portion of the beam, this portion. So it is near, suppose this is a column. For this column, this portion in the column and this portion in the beam, it means at and around the junction the nonlinearity or hinge formation occurs. So we should be careful while casting the concrete in the junction, whether it's a case of regular new construction or it's the case of retrofitting. Here are also other typical photographs during the entire process of column jacketing from foundation to top level. Here, this is the plinth beam. This is the plinth beam, and the excavation is like this. In order to accommodate, in order to make a space for the new strengthening of footing, like this. This is the footing. The river has been placed and it's ready for concreting, and this is also the new footing and it's ready for concreting. The existing footing is isolated slope type, isolated trapezoidal footing, and the addition of river as for the design in the footing in the cave, and it's ready for concreting. So we'll talk about the design and the detailing of reinforcement bar in the footing as well as column, beams, shear wall, etc. We shall discuss in another video. Today we will go for only the type of, we'll focus on for only the type of retrofit in local retrofit. I mean jacketing of columns, beams, and beam column joint as well as the strengthening of footing. That falls in the category of local retrofit. So we see clearly here, here is an anchor bar. It is anchored to the existing column. The depth of the anchor bar should be greater than 10 dia, 10 phi. Suppose if this anchor bar or hook bar is 12 in diameter, the depth of the thickness is greater than 125 mm. So, and after the uh, hole is drilled, it can be cleaned with a compressor or any type of air blower. And suppose if we have to insert the bar of 10 here, the hole should be 12 and the epoxy anchor chemical or an epoxy type grout should be placed in the hole, and the rebar is placed, and the epoxy should be placed until the epoxy is spill out from this hole, so that the bar can be anchored well to the existing concrete or existing component, and the bond between the new concrete and old concrete can be strong enough to withstand the lateral load carrying capacity of the structure. So if we look into the ring here, the lateral ties for the column, the ties in these columns are like this. It's normal because the thickness of the column is existing column is 300, I think 300 and these retrofitted columns are designed 500 It means 100 all around the periphery of the column. So it is not difficult to put this type of close two-leg stirrup in the column. It is better to put single stirrup rather than placing this type of hook. If it is not possible to place a single stirrup, we should put the stirrup like this. But in our case, in this case, the external stirrup is 10 dia, and the detailing is as for the NVC 205. And at the corner, there is a hook like this in all four corner, because here is one in the corner. There are three river, one river here, another river here, and another river here. Three rivers at each corner and one river at the face of the column. So the hooks are placed like this. The dimension of the hook should be as per the detailing practice, which can be followed in regular concreting surface, and they are tied for three vertical rivers or three longitudinal rivers and four face bar on each face. It means 3 fours are 12 for 16 rivers. There are 16 rivers in these columns, 16 longitudinal river in each column, and the detailing of footing is as per the design. And after the casting has been done or micro concreting has been done, this area should be filled by the bricks or stone masonry, which to match with the existing one. If there is a stone masonry below the plinth level in the existing structure, it is better to connect these things with the stone masonry, and if it is brick, it is better to make with the brick masonry wall. So these are all about the column retrofit as well as the strengthening of foundation. This is a typical example of retrofit column section. This is developed in section designer of the types. So I have modeled this section in section designer in order to look the performance of the structure, retrofitted structure, and compare the seismic load carrying capacity of the structure with the existing one. So we'll discuss more about these things in next videos. Here the three longitudinal rivers are concentrated at the four corners, and one river is at the face of the column. This is as for the design, and the existing column is this one with 8 numbers of river, 416 and 420 dia, 412 dia river, longitudinal river with 8 lateral ties. Here the lateral ties which I have seen in the previous slide is placed like this. In the section designer, it is very difficult or is difficult to show this type of stirrups. So the lateral ties are hook to bind these corner or edge river like this. And if we see the typical design which is issued for construction, here the corners longitudinal rivers are concentrated at the corner, as there is the maximum stress in the corner and it reduces while going along the center. So this is the typical design provided by the designer. And if we see this figure, this is the beam retrofit or strengthening of beam, in which This is the existing beam, and this one is the existing slab, and the beam is jacketed with a concrete reinforced concrete jacketing like this from the three sides of the beam. These these two bars at the top are two numbers of 25 diameter, and this is the face bar or torsional rebar, and these are the bottom rebar. They are two numbers of 20 dia plus two numbers of 16 dia rebar. This is the typical sections for beam retrofit. And another interesting thing is that it is very difficult to pour the micro concrete in the beam. So for practical purpose, we have to demolish, we have to strip this portion of the concrete where the beam has to be casted or has to be done micro concrete, and the concrete is poured from here. I already mentioned that the concrete should be micro concrete with self-compacting concrete because of difficulty in placing in compacting the concrete. So we have to cast the concrete from here after puncturing of the slab, so that the concrete goes like this from here and like this from here in the bottom part as well, and complete the concrete jacketing in the beam. It is very difficult in real field. We have seen so many difficulties while casting. There is a high chances of getting void in this area. So great care should be taken while doing the micro concreting works in the beam as well. So these are the typical section for implementing in the site for beam jacketing and column jacketing techniques. So this photo also speaks about the concreting of the column in strengthening of footing. This is the slope footing after strengthening, and these are the column jacketing. The detailing of the rebar I have already explained in the previous slide. This is the reinforcement bar placing in the existing footing. We see here the size of the existing footing is very small because these buildings were constructed maybe 15-20 years ago, and there were no clear concept about all the detailing procedure and the code compliance to make the structure as for the building code. So there may be the existing footing like this, and we have to, while doing the strengthening of column as well as foundation, this should be designed as per the current seismic codes, and the soil bearing capacity of the soil of this soil should be tested before doing the retrofit design. Or the soil bearing capacity of the structure should be checked while doing the damage assessment of the this structure. Here in this footing also there is similar type of small footing, and if we see these two footing, the level of the footings are not in the same level, and while designing the retrofit, the level difference is governed. This is a combined footing with the addition of beams to connect the two footing here to counteract the eccentricity or to transfer the load from one individual footing to another footing. So in this right figure, we see the column already casted with micro concrete. It's a very good surface. These columns are 500 by 500 because of existing columns are 300 by 300 and 100 addition of 100 while doing retrofit is sufficient for the load carrying capacity of our for seismic resistance. These all photographs were taken through the different schools which I have visited during the process of retrofitting in the 14 earthquake affected districts of Nepal. Similarly, this is the one typical example of beams and column retrofit. This one is the column detailing, reinforcement detailing as for the design, and this is the beam jacketing. The river is placed in this manner. So there are 4 rivers in the bottom, and the other 2 rivers at the side, and 2 rivers on its face just below the slab level. So here the bottom river are clearly seen, and the river are placed as for the design in the side as well, and for concreting purpose and the river placing purpose, the side of the river is punctured. Sorry, side of the slab is punctured, and after casting, it is easy for casting as well as placing the formworks of the beam, because the 100 mm from the existing beam, is filled by the new jacketing surface. So if we look here, after the casting of the column and the beam, after the retrofitting, this is the column section, which is like a new column section, and this is the retrofitted beam or jacketed beam, and the slab portion is already casted at the time of casting the beam, because the concrete should be poured, the micro concrete should be poured from the top surface of the slab, and the formwork should be put on to the extension of some portion of the slab, maybe 300 mm or 500 mm from the jacketing surface, so that the remaining portion of the slab can be casted and make a single unit after the retrofitting. These photos speaks about the wall jacketing and addition of splint and band in the wall for load bearing structure, and in the frame structure if there is no any horizontal band present in the existing structure. So if we see here, these horizontal rivers are for the sill band. The placing of this river can be are as per the design, and these are the vertical splint, and the detailing of river are as per the design. And if we see the internal internal wall, the horizontal lintel and this vertical splint are doing in order to avoid the out of plane failure of the infill masonry wall at the time of earthquake. So if we have the wall like this, suppose this is the section of the wall, existing wall, and these things can be done with the addition of band like this, for the case of lintel and sill from both faces at the same level, and these two bands are tied with a hook. The drilling of the wall throughout the wall and make a hook of the river like this in order to bond the wall and tie the newly made band with the existing wall, which can work properly at the time of earthquake. So this is the existing wall, brick wall, and this is the band added from external and internal surface with the river as per the design. The detailing of river can be calculated by looking the stress concentration in this area, and while designing this wall can be modeled as a cell element in types or shape, and the stress concentration at the edge or any location, we have to extract the maximum stress in this area, and the calculation of river is based on the stress concentration in the certain specific area which we are going to design. So by this way, the band, vertical splint and horizontal lintel and sill band can be done and casted with this. And after the casting, we get the surface. The surface after the casting is like this, with the increment of the existing surface by 50 mm or 100 mm as per the design from the existing wall. From this existing wall, I think here in this side, the protrusion from the existing wall is 50 mm, and after the plaster it is 20. If we do the plaster of 20 mm, it's 70 mm, and if we do the plaster of 12.5 mm, it is 62.5 mm extended from the existing wall, masonry wall. So this photo is taken from Garamkali School, Secondary School, Sinduli. So here is a typical wall jacketing procedure explained in a simple way. First of all, in the load-bearing structure, before any intervention, the slab should be supported with the props or any metal pipes like this we see in this photo. The slab has been previously supported in order to avoid any collapse of the structure in case of worst scenario. And after that, the existing wall plaster should be stripped and make a have to clearly show the surface of the brick with the joint raked and excavate the pocket beam below the plinth level. Yeah, this is the excavation for the pocket beam below the plinth level. We see here, this is a pocket beam in order to raise the wall rebar. Stripping of the plaster on the wall and rake joints properly. Place the rebar as per the design. The rebar should be placed as per the design and cure or wear the wall prior to jacketing works as the wall is dry. So in order to have a better bond, good bonding between this masonry wall and the new concreting, the wall should be wet, cured with water, and proper safety of the structure should be ensured before intervention. Slab is supported with MS pipes. We see the MS pipes here in the photo, and place the formworks on the wall. In the case of microconcreting, the microconcreting is done with the 6 mm down aggregate or ready mix microconcrete, which can be done in two ways. The first way is to spray the concrete, wet spray the concrete in the wall in two layers to make it to make the thickness of 50 mm or as per the design. And the second and easy way is to place the formworks of uh, required thickness of the wall to be casted and place the concrete from here so that the concrete surface should can be good enough to resist the earthquake, and the quality of the works comes from this formwork as well. So if we see this photo in the wall jacketing procedure, this is the beam, and maybe there is a column also. The columns are not seen. It means the columns and the beams has not to be retrofitted, but the wall has to be strengthened in this case, and the design was done accordingly. So these rivers are longitudinal rivers. These are, I think, 8 mm rivers designed horizontal and vertical with 150 mm spacing for both ways. And we see here, these are the hooks provided in a staggered distance of 450 mm spacing center to center in order to bond the existing masonry wall and the concrete. And we see this is the concrete face after with the placing of formworks. The thickness of this concrete is 50 mm as per the design, or this should be 100 mm. That depends upon the design. So this is the good concrete surface, and the concrete can be placed layer by layer in order to avoid the voids in the concrete. And in the top portion, we fill the concrete up by regular pouring up to this level, which is I think 200 or 300 mm below the slab level. And if it is possible, make a hole on the slab at the certain interval and cast the concrete, place the formworks in this top part and cast the concrete from this hole. And if it is not possible to do that, it can be hand sprayed with the ridge mortar or the mortar which is designed, ridge concrete, which is designed for this wall jacketing purpose. So by this way, the wall jacketing procedure can be done with the with the application of rebar and formworks. So in summary, place the reinforcement bar as for the design. Anchoring should be placed to bond the existing masonry wall and the new microconcreting. And microconcreting shall be done in layer by layer to avoid the honeycombing and the void in the wall. So bonding chemicals have to be applied in casting this joint and casting the continuation from this joint and to this existing surface, masonry wall surface. So these are the photos for steel jacketing in columns in the sides. So the steel jacketing retrofit has been used to enhance the shear strength and the ductility of the reinforced concrete columns in the existing buildings. Thinner in layer, as we see that the thickness, as you know, that the thickness of these angles are in the range of 5-6 mm up to 10 mm. So there is a minimum thickness which is light in weight. The dead load of the structure is not significantly increased with the addition of this type of steel jacketing, more suitable where there is no requirement of foundation strengthening. So if we do not have the requirement of footing strengthening, then this type of steel jacketing can be proceed from the plinth level of the structure or just below the plinth level up to the requirement of as for the design. So steel jacketing also increase the shear strength, confinement, and ductility and stiffness, as well as the load carrying capacity of the columns. So here, if we see the jacketing photos, these are the steel angles placed. These are the steel angle like this, placed at every four corners, and these flats. These are the flat plates of same thickness in order to compensate the shear, like the lateral ties in placed in doing reinforcement concrete jacketing. So, and in similar way, like RC jacketing, the anchored bars should be placed in certain intervals. The anchored bars or anchored bar are not clearly seen in this picture, but the anchor bar also placed, and after doing this, the micro concreting is sprayed in the concrete and the finished with plaster after the completion of retrofitting or jacketing. Another option for local retrofitting is carbon fiber application. It is a modern technique where strands or sheet of carbon fiber reinforced polymers, which is in lightweight, high strength, highly elastic and durable material, wrapped around the concrete surface existing which are existing beams or column to enhance the shear strength or flexural strength of the structure and improve the seismic resistance. If we see this photo here, in the columns are wrapped with carbon fiber up to the certain level where the zone of hinge formation zone at the ground floor, hinge formation zone at the ground floor. And if we see here, this is the strengthening of beam for shear as well as flexure, and here the strengthening of beams for shear as well as flexure also with the carbon fiber. If we see this photo here, this is the strengthening of slab from the bottom of the slab. The position and placing of this carbon fiber strip is as for the design, as for the retrofit design. So this concludes the local retrofit techniques. And after that, let me explain some challenges while doing the retrofit techniques. So I want to stop today, and I will continue the challenges in retrofitting works in the next video. Until then, keep watching my videos. Don't forget to like, comment, share, and subscribe my YouTube channel. Thank you.